This is lesson 13.5, which is on histograms. Histograms are another way to represent data. But first we'll do the warm-up. So it says the class average for the first social studies test in Molly's class was 85%. That was when 23 students took the test. So we know that the average, or the mean, was 85% when 23 students took the test. Then a 24th student took the test and the mean bumped up to 85.5%. We need to find what grade did the new student earn on the exam. So we know that to find the mean, or to find the average, we add up all of our scores in this case, divide it by how many students took the test, and that would give us our average. So we know that 23 students took the test. That's the total amount of students that took the test. We know that the average is 85%, but we don't know what all of the scores are added up to be. So that's what we need to solve for first. To solve for that, I'm going to multiply both sides by 23. So I'm adding my brackets. These 23's cancel out, which leaves me x on that side. And then I take 85 times 23, and I get 1,955. So I know that all of the scores added together for those 23 students was 1,955 points. Then, to find what the new score is, again, we're going to take the total amount of points that the 24 students scored. We're going to divide it by 24 students, and that's going to give us the average. So setting up another equation, I know that there were 24 students. I know that the average was 85.5%, but I don't know what the total score was added together. So there's a couple ways you could do this. You could write this as an x, you could solve, and then you could find the difference between your two answers. But what I'm going to do is I'm going to take that score from the 23 students, so 1,955, and I'm going to plus x because I'm adding on another score to get to the 24 students. So all I'm going to do is add in that score, but since we don't know it, I use x. From there, I'm going to use brackets, multiply both sides by 24. That cancels these 24s out, and I'm left with 1,955 plus x equals, and then you're going to take 85.5 times 24, and you get 2,052. To get x by itself, we're then going to subtract 1,955 from both sides. I'm then left with x equals, and when I subtract those, I get 97%. So the 24th student would have to score a 97% in order to bump the average up to 85.5%. Okay, so one thing we're going to talk about is statistics. So statistics is collecting, analyzing, and then presenting the information. So a histogram is one way to present that information. The information that we collect is our data, and we display data in graphs to make it easier to visualize. So there are many options of different data displays. On the test, you will have to be able to tell in a certain situation which data display would be best to use. So these are important notes to take. You use a circle graph to represent data as parts of a whole. So if you're given percents or things that add up to 100, add up to a whole, you would use a circle graph. You use a stem and leaf plot to order a data set. So you use a stem and leaf plot to put data in order. It must be numbers. That's what this numerical data means. You use a line graph to display data over time. So if you're keeping track of something over a certain amount of hours, days, months, years, you're going to use a line graph to show that. You use a bar graph to display data in distinct categories. And then the last one we're going to talk about is a histogram, which compares frequencies of data that are grouped in equal intervals. And that's what we're going to talk about today. So anytime you see those words frequencies or intervals, you're using a histogram. So here's an example of questions that are similar to what are on the test. So it says you want to display a contribution made to 4 different projects. We need to figure out which one of those choices is best to use. So I know we're displaying data and there's 4 different projects. So looking back at my list, circle graph, we're not comparing parts of a whole. Stem and leaf plot, there's nothing to order, so it wouldn't be that. Line graph is data over time, not what we're looking for. Bar graph is distinct categories. Well, it says 4 different projects. That's distinct categories, so this would be bar graph. The next one says you record the percent of students in class going on spring break. So looking up at my list, circle graph, that's where we use percents. So this one would be a circle graph. The next one says you record the amount of snow that has fallen every hour for 2 days. So again, I'm looking up at my list. Circle graph is parts of a whole, not what we need. Stem and leaf plot is ordering a data set. That's not what we're looking for either. Line graph is displaying data over time. Well, we're talking about hours and days here, so that's exactly what I need. Line graph. And then the last one is you record the grades of everyone on the Chapter 7 test in percent intervals. When we see that word intervals, we're going to use histograms. And that is what we're going to be talking about in this lesson. So frequency is how often something happens. If something happens frequently, that means it's happening a lot. Frequency table shows the frequency of the data, and a histogram uses that frequency table and organizes it into intervals. So, key things about a histogram. There's 1 bar for each interval. The height of the bar indicates the frequency, and there is no space between the bars. If you add space between the bars, it then creates a bar graph. And that's not what we want. Histograms have no space between the bars. Frequency tables. So this is what a frequency table looks like. You need one of these before you can make a histogram graph. So frequency tables, you need headings, you need intervals of equal size, and it has to cover all the data. You need to make tally marks with the intervals, and then you write the frequency. So looking at this first example, we have the interval of 500 to 599. There is 3 tally marks, so that means there were 3 data points that were in between those values, and the frequency is then 3. Okay, making a frequency table. So this gives us a blank frequency table. What we need to do is we need to fill this in. In order to do that, we first have to figure out what our intervals are going to be. I have to look at this data that I'm given, and I have to find my highest and my lowest value. So here I see that the highest value is 80. Then my lowest value is 54. So I need for sure this to start at 54, and we have to get up to 80. So I'm going to find the range. So I'm going to take 80 minus 54, and I'm going to get 26. From there, I know we have 3 rows here. So I am going to divide this by 3. I then get 8.6, really close to 9, so I'm going to round that up to a whole number of 9. So I know that my intervals have to be 9, okay? It's really easy to say 54 plus 9 is 63, so 54 to 63. But you have to be careful, and this is where I encourage you in 7th grade to count with your fingers, because this is where it gets tricky. So if you start with 54, 54, 55, 56, 57, 58, 59, 60, 61, 62. 54 to 62 is an interval of 9. Then the next one, we have to start at 63. Now do it with me with your fingers. 63, 64, 65, 66, 67, 68, 69, 70, 71. So 63 to 71 is an interval of 9. Then we have to start at 72. And on your fingers, we're going to count again. 72, 73, 74, 75, 76, 77, 78, 79, and 80. So that covers all our data. So we're good there. Then what you're going to do is you are going to tally up how many data points are in between each of these intervals. So I think the easiest way to do this is to just go through your data and to make tally marks. So I start with, 80, that would go here. 54, that would go there. 60, that would go there. 61, there. You finish filling this in. Once you are done, you should have 7 between 54 and 62. You should have 9 for 63 to 71. And you should have 4 for 72 to 80. And our frequency table is done. Okay, so then we're going to take that frequency table and we're going to convert it to a histogram. So here's an example of what a histogram looks like. Histograms have some things in common with a bar graph. They need a title, they need a scale that starts at 0, they need equal intervals, and need to label the axes. Some things that are different is that these bars show frequency, so how many values, so those intervals, which we just talked about. And then the bars are right next to each other. So with that information, we are going to use our frequency table that we just made together, and we are going to convert that to a histogram. So I'm going to make my graph just like a big L. I first need to add a title. So my title is going to be Teacher Heights. Okay, then looking at my list, need a scale that starts at 0, equal intervals, and label both axes. So I'm going to label both of my axes. My x-axis is going to be heights in inches. And my y-axis is going to be teachers, so the amount of teachers. Then I'm going to add in my intervals. So we had 3 intervals and we had 54 to 62. We had 63 to 71. And we had 72 to 80. And then my frequencies for teachers were 7, 9, and 4. So I'm going to count up by 2s on my y-axis. So we'll have 2, 4, 6, 8, and 10. And now what we're going to do is we are going to draw in those bars for our histogram. So the interval from 54 to 62 had 7 teachers. So I'm going to bring this bar up between 6 and 8 because that's 7. I'm going to make it fairly thick. And then for 63 to 71, there were 9 teachers. So here's the key. I'm going to have this one touching that previous bar, and I'm going to go up to 9 and bring it down. So again, those bars have to be touching, no space in between. And then for 72 to 80, there were 4. So I'm going to start my bar at 4 and bring it down. Again, no spaces in between. And our histogram is finished. Okay, interpreting a histogram. So using the histogram, which business sector, so trade or services, has more states with the number of employees in the interval 1001 to 3000. So I need to look 1001 to 3000 on both of these. And we're trying to figure out which one has more. So I look at my frequencies, and this looks about 6 and 1, so 7 total there. And this looks about 8 and 3, which is 11. So which one is greater? Services. Okay, just a couple more examples. This is interpreting a histogram again. Letter A says what interval has the greatest frequency? So the one that goes the highest. So the interval is 30 to 34. Letter B says about what percent of the participants finished in less than 30 minutes. So we are looking for the percent of participants. What I need to do to find the percent is to figure out how many total. So I'm going to look at each frequency. So 20 to 24, there were 5. 25 to 29, there were 6. 30 to 34, there were 10. 35 to 39 was 7. 40 to 44 was 2. So when I add those all together, I get 30. And we're looking for less than 30 minutes. So less than 30 minutes would be 5 plus 6, so that's 11. So 11 out of 30. And I'm going to my calculator then take 11 divided by 30. And I get 0.36 repeating. To change that into a percent, I bump the decimal over 2, and I get 36.6 repeating percent. And we're going to skip that last one. Okay, last one. A veterinarian recorded the weights of animals in a histogram. Which question can be answered using the information from the histogram? Letter A says how many animals weigh 4.9 pounds? Well, with a histogram, we can't tell because we're given intervals. We're not given exact amounts of weight for this example, so you cannot tell how many animals weigh exactly 4.9 pounds. Letter B says how many animals weigh between 5 and 10 pounds? So between does not include either of those numbers. So 5 to 9.9 does not include 10. So we cannot tell how many weigh between 5 and 10 pounds. How many animals weigh less than 8 pounds? Well, there's no specific 8 on our intervals, so we can't use that. And then how many animals weigh at least 15 pounds? So 15 pounds or more. Well, we can answer that because we can tell how many animals weigh 15 to 24.9 pounds. So D would be our answer.